guys, in this video I'm going to continue with section 6.5 about finding real roots. So I briefly talked about this but didn't give it a formal name in our last video, but we discussed that whatever the degree of a polynomial is, that actually tells us how many zeros it should have. This can include if there's a root that occurs more than one time. So what I mean by that is, for example, sometimes when we factor, we get the same factors, right? We get x plus 1 times x plus 1, or x plus 1 squared if it's in factored form. So that's the same number, right? The same 0, I would get x equals -1 from both of those. So we have something called multiplicity, okay? So if a root occurs more than once, we call that the multiplicity of the root, okay? So if it occurs once, the multiplicity is 1. If it occurs twice, the multiplicity is 2. If it occurs 3 times, the multiplicity is 3, so on. So if the multiplicity is even, okay, then it is going to touch. So for example, let's say I had x plus, let's do this, x minus 2 squared. So there are two x minus 2's. So my 0 is at x equals 2. Well, if the multiplicity is even, so it's occurring twice, at 2, that's my 0, the graph is going to touch and bounce back, okay? And it can do it either direction. It can do underneath. We'll talk more about that later. All we need to know right now is it's going to bounce, okay? So if it's even, it's going to bounce. If it's odd, so if it's something like this, right, in factored form, I have x minus 1, then at 1, the graph is going to cross, okay? So it's going to cross at 1. So even multiplicity, it bounces. Odd multiplicity, it crosses. Okay, so we are going to do what we started working on in the last section. We are going to graph this using either graphing calculator or Desmos. Okay, I'm going to do one on the graphing calculator and then repeat and then do the other ones on Desmos. Okay, so reminder to enter an equation, you go to y equals. We can clear any others that are in there. I'm going to graph x cubed minus 7x squared plus 15x minus 9. And then I'm going to hit graph. Okay, and we are going to try and get nice zeros from the graph. Okay, so I know that I should have 3 zeros, okay, based on it's a third degree. I'm only seeing 2 here, and we'll talk about that here in a second. But this one actually looks nice. It looks like it's nicely crossing through 1, so let's check it. So we're going to do second, calc, 0, and this is where I do the left bound, right bound. So my blinking guy, I want just below 1, and I'm using my right arrow now to go right bound, enter, guess, enter. We got a nice number of 1s. So from the graph, and I do want you guys to practice writing from the graph here, because then I'll know that you didn't actually do any algebra or anything to find this 0. You got it from using technology, which is fine. We're showing you how to do that. But we want to know which ones you're getting from the graph and which ones you're getting from algebra. Okay, so we got x equals 1, maybe 3 as well. So let's try that one. So 0. Okay, we want left bound, so I'm going to move over a little closer to 3, hit enter, and then I'm going to go to the right of 3 and hit enter again for right bound, and then guess, and no sign change. Well, apparently I am going to use Desmos on this one too. I didn't like that one. I probably have to reset my memory here, guys. Actually, I will show this to you because this is a strategy if anything ever goes wrong for my graphing calc. This is usually what I do. I go to second and then the plus sign where it says memory. Second and then plus sign. And then if you go to reset, it restores it to its factory setting. So if there's anything weird, it will go back to normal. So you go down to reset, and then all RAM, and then to arrow down to reset, and hit enter. And then it clears it for you. So let's maybe try that one more time. So x cubed 7x squared plus 15x minus 9 graph. All right, so we already know 1's a 0, so let's try the 3 again. All right, so let's go second calc 0, left bounds and right bound. Yeah, it doesn't seem to like that one. Here's my guess, you guys, is it looks like it's at 3, but if you notice, it's bouncing at 3. So let's check it on, well, here, let's do this. Okay, so we can't get that other one from our graph, not for sure. It looks like 3, but it could be like 3.01 or 2.99. So I'm starting with a third degree. Let's divide out the 1. I know that's a 0, so let's figure out what the other two zeros are from synthetic division. Okay, so bring down the 1, multiply, and then add. All right, we got a remainder of 0, so that confirms it's a 0. So this is a quadratic, a second degree, because I started with a third degree. So I have 1x squared minus 6x plus 9. And actually, this one does factor nicely, guys. Numbers that multiply to be 9, that add up to be negative 6, are negative 3, negative 3. And so that's what happens here, is I could write it as x minus 3 squared. So the 0 is x equals 3, but it has a multiplicity of 2, okay? So here's how we would write that. Zeros, so we would say x equals 1. I usually just use the abbreviation multiplicity of 1, right? It only occurred once. From the graph, it crossed through the graph at 1. At x equals 3, it has a multiplicity of 2. Because it is occurring twice, right? X minus 3 and x minus 3, and that's why on the graph it bounced there at 3. So those are our zeros, and we are indicating what is the multiplicity of each 0. All right. Okay, this one I have ready to go on Desmos. Okay, so flipping over here. All right, so this one graphed. Okay, again, I can use these tools over here on the right to zoom in, zoom out. So I'm going to click right on this one. It looks like negative 5, and I know for sure it looks like it's going to occur twice, right? So from the graph, we know x equals negative 5. From here, we also know it equals 4. Now, this one is a oh, sorry, maybe I'm graphing the wrong one. Oh, no, I'm not. Okay. So from the graph, we have x equals negative 5 and x equals 4. And because it's bouncing at negative 5, we can assume that it's occurring an even number of times. So it can occur 2 times or 4 times or 6 times. Well, because this is a third degree, I can only have 3 roots. So this one's going to have a multiplicity of 2, okay? Because that'll give me 2 roots here and then the third root here. So that matches up with my degree, okay? And I was able to get all of those from the graph. I don't necessarily have to use synthetic division. You can, and it will just verify that those are the zeros, okay? But if it's really clear from the graph, you don't need to do the algebra to get it as well. All right. Let's try this one. All right, so from the graph, back to my Desmos here. So we have x cubed minus 9x squared. Okay, so this one, you guys might notice that it is crossing at 3, but notice it's crossing a little bit flatter. So this is something we're going to recognize. I'm going to point out here in a second. So it is crossing, even though it kind of like sits on it and then comes back up. So we know from the graph, we have x equals 3. All right, I can't see any other crossing points nicely. So what we're going to do is we're going to say from the graph, x equals 3, and we're going to synthetically divide it out. So then I can get a quadratic and solve using the quadratic formula, or something similar. Okay, so I'm going to do 1, negative 9, 27, negative 27. Let's see, we get 9. And we do get a remainder of 0. So here I have x squared minus 6x plus 9. We just saw one like this, right? This factors into x minus 3 and x minus 3. So x equals 3, but this one actually occurred 3 times, right? We saw it from the graph, and this verified, hey, once I divided out 1x equals 3, I still have 2 more zeros there as well. So my graph, or my zeros, are x equals 3, multiplicity of 3. So that's actually what happens, you guys, when my multiplicity gets larger. So if my multiplicity was just 1, so I'm actually going to turn this one off and I'll show you here. So if I had just x minus 3, okay? So it's crossing at 3, and notice it's crossing in a linear fashion. It's going directly through. As soon as I add an exponent that's higher, it's now looking like a cubic at that 0. So that's what happens as our multiplicity increases. If I do a 5th degree, it gets flatter and flatter. 7th, flatter and wider. Okay, and the same thing happens for 2, 4, 6. They all look kind of like a miniature parabola, but they get wider as the degree gets higher. So it is good to know the difference between a 1st degree multiplicity and a 3rd. Those are going to be the ones that you guys are going to see the most. So a 3rd, it's definitely like flatter going through that 0 than it is if it's just a multiplicity of 1. All right, we have 2 more here. And sorry, I started writing, this is the wrong example. All right, so let's graph this one. I think I had this one ready to go as well on Desmos. Yep. All right. So this one is not nice, so we're going to end up solving for that one after using synthetic division. This one is nice, so we got -1. Here I get, I'm going to zoom in. It looks like we have 2 there. This is the other nice thing about Desmos. It's really nice to zoom in. Not nice. 2 is nice. So we got -1 and 2 nicely from the graph. So we're going to divide those out and get a remaining quadratic, and then those are going to give us those not as nice roots. Okay, so we're going to divide out -1 from our polynomial. So we have 1x to the 4th, -1x cubed, -5x squared, 3x, and 6. I messed up somewhere. 1. Let me check my coefficients. -1, -5, 3, 6. Bring down the 1, multiply, add, multiply, add, multiply. Oh, we're good. There we go. All right, and we got our remainder of zeros. We should. Okay, now I'm going to divide out the 2 from this guy. All right, multiply, add, and again we got a remainder of 0. So I started with a 4th degree, I divided twice, so this is now a 2nd degree. 0x, and this one I actually don't need to use the quadratic, I can just use the square root property, and I get x is plus or minus the square root of 3. So there are my 4 roots, and we see the rational root, the conjugate theorem kind of coming out here where I have the plus and the minus. So zeros, I have -1, 2, plus or minus root 3, all just occur once. Okay, so if we go back to the graph, we can see each of those roots, it's crossing directly through. So none of them have a multiplicity greater than 1. All right, last example here today, you guys. It says find the missing factors. So imagine this is something we got from the graph, right? So this is the factor, but the 0 would be -3. So I'm going to divide it out and see what quadratic I would have left, and then see if we can factor that remaining quadratic. All right, so we've got 2, 11, 18, 9. Bring down, add. Okay. All right, so here's our remaining quadratic. 2x squared plus 5x plus 3. All right, well, we're pretty sure it can factor because it's asking me for 2 factors, not just 1. So I'm going to go ahead and do my reduce and bottoms up. So numbers that multiply to be 6 that add up to be 5 are 3 and 2. All right, reduce and bottoms up with the leading coefficient. So I get x plus 1 and 2x plus 3. All right, so there are my remaining factors. So x plus 3 was 1. We divided that out. These are the remaining factors. So this guy factors to be x plus 3, x plus 1, and 2x plus 3. All right, that is all for this video, guys. Thanks for watching.